And now live from Mo's house, it's AWS's Howdy partner. Take it away,
It
Mo.
sure is. All right. Hey, y'all, what's going on? Glad to be here for, I think, my 4th episode of Howdy Partner, but the 14th episode. AM, I think it's the 14th. AM is actually with us, but he's the ghost host. We have 2 wonderful new faces here. We have Nika from New Relic. Nika, do you want to introduce yourself?
Hey everybody, how's it going? I'm Nika. I'm a serverless developer advocate with New Relic. We're going to talk about observability today, and I'm glad to be here.
Oh yeah. And then we have Braden, my co-host. Braden, this is your first episode of Howdy Partner, isn't it?
That's right.
Are you excited?
Pretty pumped. I'm really excited to be here.
Nice. So apparently you have a demo for us. We're going to be talking about serverless today, almost always when I'm here, and when Nika's here, right?
Yeah.
And Braden's going to show us. Exactly. So Braden, go ahead, kick us off, man. What do you have to show us today?
Awesome. So I have a really exciting topic for you guys today. It's called structured logging. Now I know that's something that's been around for a little bit, but I know sometimes when we're developing, we easily just want to throw out the console log thing and then just leave it there, and that's what we consider logging sometimes. So we're going to take a step back today and just think about how we're going to make those logs a little bit more accessible and searchable and queryable. And the way we're going to go through that today is taking a look at my fictitious business, the Gourmet Tater. So AM, if you want to throw the screen on real quick, let me put that on for you actually.
Nice.
You're gonna have to take that over. There we go.
Anytime someone says that logging is more than just console.log or print statements, piques my interest. I don't know. Maybe you'll teach me something.
Here we go. Well, this is what we're gonna do here is we're taking a look at my business here, the Gourmet Tater. All right, it's a new high-end restaurant that specializes in potato-based dishes, especially tater tots. So we're a relatively new company with scrappy internal business operations and processes that we're starting to outgrow just a little bit. However, despite our scrappiness, we've retained a 4 stars on Yelp. But I think the Gourmet Tater is actually going to be a 5-star restaurant on Yelp. And so being the data-driven business owner I am, I decided to take a look at the reviews and compare them to what the servers are telling me. So let's take a look at our internal dashboard here. This is the dashboard I use to run my company. We'll go ahead and jump into these reviews here. Now we see there's a handful of them. There's a discussion about how the food took a little long. 3 hours seems like a long time to wait. I'd be pretty mad myself. Looks like some messed up orders. And looks like the waiter here did that thing where they fill up your water every 5 minutes and end up ruining a special moment for somebody. So, that's interesting. So I know that this is important to look over reviews. Let me go ahead and take a look at what the servers are saying. Okay. So here are some reports that I've asked for servers to kind of write down.
I'm gonna interrupt you you real quick. These aren't servers as in ServerX. These are
yes,
servers
that is correct.
These
are
okay.
Waiters and waitresses.
You were saying servers, and
I was going to say, this is a serverless episode. We don't.
Yeah.
That is right.
Watch yourself, Braden. Watch yourself. Is all I'm saying.
So yes, thank you for specifying that. Yes, these waiters and waitresses have been able to give me a little bit of data and reports on what's happening inside the restaurants when I'm not around. And let's take a look at some of these reports. So we see here that one of the waiters said that they seated 3 people at around 8:30 p.m. Okay. They see that they refilled their water 2 times every 10 minutes. I guess that's all right. Now the cook time, I imagine they mean that how long it takes for them to cook the food. I'm not quite sure. Took about 20 minutes, and then there were 3 dishes. I'm not quite sure how many people were at that table. Maybe there were a couple people sharing. And then this third waitress wrote down that it took about 30 minutes kitchen time. Again, I'm assuming they mean That's how long it took to cook. And then this person or party just ordered the gourmet ramen. So let's take a step back and digest this a little bit. We can see here that there are 3 different reports from different employees, each saying their own different thing, their own different format. You can see here the discrepancies, cook time and kitchen time. I mean, as an owner, being at the high level that I am, I'm not quite sure if that means the same thing or if it means something different each. And at the same time, I also don't know, or there's not a standardized data across any of these reports. I don't know how many people are in the party for each of these tables.
I like this. This is a very good. I've seen this with electronic medical records as well. It's like when everybody's just putting in whatever, then it's very, very hard to compare one to the other. What are you actually looking at?
Exactly. Thank you. Exactly. So that's what we're going to look at improving today. And you can see here at the bottom, there's an improve the business button, which if you didn't know, every business has this button, and sometimes you just forget to click it. So let's go ahead and do that. Boom. There we go. So what I've gone ahead and done is I had these waiters and waitresses have a standardized report of each time they serve a table. And I've made it simple for them so they don't have to do more writing down. But what we have here is all the different data points that I think are important, as well as the structure of what that data should look like. So let's take a look here. Table 1 had seating at 8:30 with 3 adults and 2 children. And we can see all the order that they have. And then we have all of those fields defined as well. So I know cook time means how long it took for the food to cook across all of these different tables. So with this, I as a business owner can now look at my business and know the context of each of these individual instances. Now, if we think about this in terms of logging, how could this help us? Now, let me go ahead and pull up a quick example here. Now, that little JavaScript here, showing you what that kind of looks like in code, and this is super simple here, where we create a JSON object up at the top.
Braden, would you mind making that just a bit bigger?
Absolutely.
For us?
And let me zoom that in. There we go, nice and big. So we create a JSON object up at the top to be able to help hold all our different statuses and whatever we want to hold for the debugging or the log. And as we go through and stuff happens, we can go ahead and add some of those values to these keys. And at the end, we can have a logger instance that will just push that out to whatever uses or holds our logs or analyzes it. And in that way, it'll look exactly like here, where you have a standardized report or a standardized log that has all the context you need, and you know what it all means because all of the fields are going to be the same. So that's nice. A little bit about standardized logging. Did you want to say anything, Nico, or sorry, Mo?
This is critical stuff because, generally, especially when we're working with serverless tools, like there's tons of logging that you can do. And when you're dealing with asynchrony, you're going to be dumping in huge amounts to your logging service. And yeah, if you don't do some kind of structural input, like it's going to be impossible to find stuff. And I was going to talk about this in my thing, but when we talk about observability, this big buzzword, structured logging is a huge piece of that, right? And in fact, actually, I guess that points out like when I try to define observability, this is kind of it, right? Like, let's say that we just took away just the structure of this, that we changed the field order and maybe changed the field labels. All the information would be in there, right? All the information would be in the notes. Maybe someone wrote a 3-paragraph essay on one of them, right? So all the information is in there. So how is the observability better when we have structured logging? It's because of the time that it takes us to know what is going wrong, right? And so observability is not necessarily about putting new information in, new instrumentation or new code points or what have you. It's just about that when you're in a crisis or just have a question, that it's faster to find the answer.
Absolutely.
Yep.
Thank you.
Braden, I did have a question for you. So you mentioned that your business was scrappy at first, and you showed us how the notes were a little weird, and then you hit the improve the business button. Do you have to, like, is structured logging something that you have to do when you decide, hey, we're going to be less scrappy, or hey, we're just going to formalize everything a bit more? Or can you do structured, like, is it easy to do structured logging whenever, at the very beginning of starting a project or starting a business? What do you think?
Absolutely. And I'll give you the typical answer that typically happens in tech, which is it depends, right? However, their general rule of thumb is that you could, if you wanted to, you could create some kind of standardized log or object that you could use throughout the beginning of your application and evolve that as you need it. Or if you really are on a very agile or rapid timeline, you could survive with the console logs, or at least a very simplified version of this logging with an object. And in that way, you'd be able to still receive all that context without having to dedicate a lot of time to creating a whole framework for the logs. And so to answer your question a little bit more shortly or directly there, you could if you needed to, or you could also make do with what you needed to do with or have until a point where you did need to evolve.
I got it. I followed that. I'm not sure if everyone else followed that, but I followed that. All right. Why don't we welcome, I think, been on for a bit, welcome the new audience, Braden, and then pass it over to Nika. She can get started.
Absolutely. AM, if you want to take off the screen share while I introduce Nika here. So for those that are joining us, welcome to Howdy Partner, where we bring on a new partner every week to see what cool things they're doing. So today with us, we're joined by Nika with New Relic, who will be showing us how to gain greater visibility and observability, or distributed observability. A lot of words and syllables there.
Buzzwords.
So Nika?
Big buzzwords.
Yeah. So, all right, let's start sharing a screen. Let's do it. I'm taking over screen share.
Take it over.
All right, everybody, let's present that. Why not? This is not going to be a slide. This is like, I got 2 slides to show everybody. The rest of them are just for me to remember what's going on. But thanks for coming out. We got a good group of viewers. I'm Nika. You can call me Nika. I'm on Twitter. I think I'm in the bottom here too. You can see that I'm on Twitter at Serverless Mom, or I'm on Twitch every Monday. Actually, at this time, at twitch.com/Nika. The event's recorded. I guess you probably all knew that, so fantastic. So we're going to talk. Oh, yeah. Hey, before I get to that, I have a couple questions for the chat. And anybody who replies in the chat today, I will be entered to have me send them a Raspberry Pi 4, which I have a couple running here in the house. They're pretty fun. But yeah, answer some questions, ask some questions in the chat, and you'll be entered. So yeah, Mo, if you can remember to send me a dump of the chat when we get done, I would super duper appreciate that. Or I guess AM Ghost Host. Save me, Ghost Host. Save me. So first question, if people want to answer it in the chat, is who here is running serverless in production right now? Just yes or no in the chat. I would super appreciate it. Yeah, we're going to be talking about, I'll give you the minute to answer that. Actually, you know what? I gave up in the end. I do have the Twitch chat open on my phone. I couldn't live without seeing the Twitch chat. I need to know I'm real. I need to know I'm not a ghost. That's the thing. I think I'm worried I'm a ghost every time I'm in one of these things and I can't see the chat. I was talking to somebody who didn't realize that they were muted we were planning an event, and we went like 10 minutes where he'd been saying stuff and just none of us had heard it. And he's like, oh, I've been muted this whole time. And I just made a joke, just completely off the cuff. I said, what were you, the middle child? You're just used to being completely ignored? And he's like, yes, I was the middle child. I felt so bad. I was like, oh, dude, it's all right. We're here for you now.
Ouch.
So, okay. Yeah, of course you're running them in production. Awesome. So not a ton of people who are running serverless in production. No worries on that. Some people who are, which is rad. So, is this where I started? This is what I want to start with? That's not what I want to start with. Hold on. Let's do this in a different order because this is where the conversation was taking us. Okay, so let's before the problem. It's a problem with Braden's restaurant, actually. People are going and checking out at the restaurant, and they say, uh-oh. Anytime someone tries to use a coupon, the process loads very slowly, or it times out. Okay, so this is our theoretical problem that we're going to explore throughout the rest of this call. And this gets me to this question that is so key, which is what exactly is observability? Everybody talks about it, how do you get it? How do you increase it? What does it mean? Observability is just how quickly you can understand your problem. And that means that no additional metrics, no additional software tools are necessarily going to increase your observability. So if you are tossing a ton more metrics, if you put for example, if you put a log statement on every line of your code, would you have more observability? And the answer is no, probably you'd have less observability, right? Because if you ever look through your logs, now they're suddenly clogged with a bunch of junk that you didn't need. So yeah, that's kind of the thing I want us to think about when we think about observability is not just one simple thing. It's not just a simple idea. It is about being able to see a little deeper into our problem and also understand it quickly. So weird stuff affects observability. Something that affects observability is if one of your senior developers leave, your observability just dropped. Because the dashboard is the same, right? The dashboard is identical, but the ability to understand it has just decreased, right? You ever look at someone else's log statements, right? Mine contain a lot of boop, right? When I'm working on my other, contain a lot of yes or checking.
Made it this far.
Yeah. This line
stopped
executed.
Here.
Yeah. And actually, what I'm going to get us into in a little bit is talking a little bit about how you can try doing both increased observability and structured logging just kind of on your own little demo projects without adopting any tools or anything additional. So, hey, we spent a long time not looking at any code, and I'm starting to get itchy because I haven't coded anything, and it's already been 17 minutes. That's too long. Let's go look at some code. Yeah.
Let's get into it.
So, this is my Lambda that I have created. How's that? Oh, no. Come on. Let's get serious here. How's that for the display? Can we see the text pretty well on the screen? AM, help me out. Help me out, Ghost Host.
That's really good. I think
it's good now. Yeah, I would say you could.
Okay, well, I'm not apologizing for the past, AM. I don't have a time machine. Okay, all right.
Know.
So, I'm sorry.
Wow.
Yeah. Let me know if anything is unclear. Let me know. So, this is a very simple Lambda that I created. It's only, how many lines long is it? So it's 50 lines long, so it should be pretty simple to understand. And what does it do? Hey, let's start by seeing what it does. It creates mission statements or slogans. It creates elevator pitches for tech companies, okay? You go to this URL.
Can we share the URL with the chat?
Yeah. It's in the GitHub repository. It's on the README for the GitHub repository too. I mean, It's not much of this code, so feel free to go to the GitHub repo link and take a look. But yeah, please, if you want to grab this, I'll toss this in the chat. No, I won't, because I'd have to stop my screen share, which I don't want to do. If anybody wants to go to the GitHub and toss it in the chat, you're free to.
I got you.
So we pledge low-code chaos engineering and monetize settling out of court. That sounds good. That sounds like a good one. We migrate no-code deliverables. I guess no-code came up twice, and monetize replacing your microservices with one huge Lambda. This seems awesome. Okay, this is an awesome microservice that I have created to create these elevator pitches. So let's see how we do that. So initially, right, this, so the first thing that we see here is that this is not like doing any fancy AI or any kind of Markov chaining even. It's just like a large collection of possible Mad Libs plugins, right? It's a bunch of terms that
This isn't GPT-3?
No, it is not.
Did you catch that discussion on Twitter? GPT-3 and
Yes.
This is okay. This is not GPT-3. All right, we're not on the cutting edge of machine learning here.
Yeah.
All right.
This is not large corpuses of extremely low signal text and like various techniques. There's a guy, this is a professor, and he was kind of a jerk, so I'm not going to say his name, but he would like submit papers to like postmodernist thought journals that were just gibberish. And he's like a poli-sci professor. And he's like, the unending imperialism of the quantic moment does push the time, and we get them published. And like, journals have had stuff published that's like either ML created or is just like a series of like very, very low value text for a while. So the GPT-3 thing is not that exciting. Please go browse through Amazon ebooks and tell me that GPT-3 really scares you. Like there's plenty of gibberish text out there that is like low meaning that people still are out selling and trying to pass off as.
That's a hot take. That's a hot take.
Didn't mean to get a GPT-3.
No, totally kosher. That's a hot take. I feel like a lot of the big Silicon Valley folks would beg to differ with you, but we'll see. We'll see what happens.
Yeah, there's a thing called Baumol's price disease. Have you heard of this one? It's an economic theory where like some stuff mechanizes and drops in price. So like pin makers or hat makers, right? Their products drop in price. And some things cannot be mechanized at all. And those things experience extreme pressure. So like an example is live opera performances, right? Like as other pieces of music and entertainment are mechanizing and getting web and distributable, opera performances are not. And so those exist under a ton of pressure. And so the other example is like classroom teaching. It's like, mechanization doesn't improve the situation much at all. Anyway, that's the thing to think about. Read Marx, kids. Read Marx, kids. Nothing like looking at some new AI thing and being like, Marx foresaw all of this. All right. I'm no longer distracted, and I'm talking about Lambda code. So we create these arrays, or like I create these arrays, whatever. They just toss these things in at random, and which actually took a little bit of like grammar thinking. Like it's a little hard to come up with like grammar that would always work together. It's kind of fun to think about. But anyway, so then we need the AWS SDK, which this actually should stand out because it's like, wait a minute, this thing can't just be returning a phrase because you don't need the AWS SDK to just get requests and return a string. So sure enough, if you look 2 lines down, you're like, oh yeah, the one thing that I'm doing additionally is that we're going to write each motto that we make up, we're going to write out to DynamoDB, which is actually because the whole purpose of this thing is actually to have something that I can measure interesting performance information from. So it needs to like touch a whole bunch of other services. So later it'll like use SQS and a bunch of other junk too to create some performance data that's actually interesting. Okay, so we bring in crypto just to generate a random ID. That's why we bring that in. And then we create our document client. That's early. We'll talk about that. We'll talk about that later. It's a secret. We'll help us later. Okay, so we generate that UUID because, so how can this thing fail if it's writing out to DynamoDB, right? DynamoDB is not picky about the structure that you send stuff into. That's the whole point, right? It's a NoSQL database. So yeah, if you send invalid objects, sure, but that would fail like at the function level. That's not going to fail. DynamoDB is not going to yell at you because it'll never get that far. But what it will fail at is that you need to have some kind of key on each of your records. And the chances are not incredibly high, but they are real that you could generate the same phrase twice out of this. And also just, like setting the phrase as a key is like, come on, let's act a little real here, right? We want to have a key and we want to have the phrase that we're saving, right? So we generate this key. How's the chat doing? Is anybody mad at me yet about how bad my JavaScript is? No. Good.
Not at all.
Tater Chip Jones, you did miss all the potato chat. I'm only talking about economic theory from the 1900s. I'm not talking about potatoes. Now I'm thinking about tater tots.
Let's just start the show over. Let's just start the show over, and this can be Howdy Partner.
Potato stuff.
Nika talks economics. Nika talks economics with potatoes.
And we all swap potato recipes. That sounds good.
Oh yeah.
Okay, here's the one line of code that is actually good in this entire thing is that to select a random word, I wrote a function to do that instead of re-implementing over and over again the randomizer. I actually we could do this as a 2-dimensional array. That would be fun, an array of arrays. And then we would only have to have one function to do this, but whatever. We wrote a random word selector. It grabs a random word. If you would like to know how to, in the single line, grab a random array member, I encourage you to look on Stack Overflow and use the first solution that you find. Okay, so.
Whoa! You can't just give away everyone's secret.
Yeah, right. Sorry, that's how the senior engineers do it. So you kids work really hard and ask yourself with each line: is this functional programming? Is this functional programming? Okay. So every Lambda needs to have some kind of handler, right? Because Lambdas, as we need to remind ourselves, they're not full-blown servers, right? They take in an event, and it is an event that triggers them from somewhere. And so the Lambda execution environment must be able to find this handler that will take in that event and do something with it. So right now it takes in that event, and you can see in my little code highlighter, I think, if your color vision is good, that this event is kind of gray because I'm declaring a variable without using it. And that makes some sense, right? Because this Lambda is just going to get a request for pitch, and it's going to return that string, right? I don't really do anything with that event as it comes in, but I do have to do here. It'd be nice to keep track of what the heck that event is at some point, lock that out. Hey, let's do that now. I don't know, Oh, unstructured logs. We'll see a better way to do this in a little bit, but yeah, let's console log out that event just to take a look at it in our logs if we want to. Save those changes. Okay, so here's the message. It's just we and then a bunch of these random things. Maybe I should make it clear what order they're supposed to come in. Doesn't matter. Okay. And then we write it up to DynamoDB. So here's a tiny little bit of tech debt. The parameters on this, I just have hard-coded what the table name is, which is not great, right? It would be better to have this as a Lambda environment variable that's available to the Lambda. That would make scaling a little bit easier in few environments. And obviously, this will be, once the service really takes off and I have 1 million users, that's when we'll try to migrate this to someplace else and find the table name failing. So right. The nicest thing about that would be to be able to have a staging environment where if it's hard-coded like this, right, it's always going to hit the production table. So we don't want to go in and have to change that. So yeah, we want to change that to an environment variable soon. We use the UUID, or we generate the UUID, and then we give it the message. We write it to the table. So now we have to do two things. We have to write it to DynamoDB, and we want to return this string back to our initial requester. So who can tell me in the chat how to find the IP address or URL for your Lambda? Go ahead and answer in the chat. If you tell me a way to find your Lambda's IP address, or actually, no, not IP. If you tell me a way to find its URL, I will send you 5 Raspberry Pi 4. I will just send them to you. I'll put them in a big box, big screen, and I don't have to check the chat to find out because you can't do that. Lambdas do not have URLs, right? Lambdas only take in events from some other service, right? So in this case, because we were sending these requests to a URL, which sort of, it had that gibberishy look. It looked like it had been machine generated. Maybe it pointed right to Lambda. It didn't, right? It points to an API gateway somewhere. And that is what passes on an event to that Lambda, which means that we can't just return a simple string back and have this work. We need to return something that actually looks right to that API gateway. So the first thing we do is we try to go ahead and write up that object to DynamoDB. And then we try to return back to that API gateway. We put this all inside of a try-catch, one, because that's just the right way to write code, and also because this might not work if we have not constructed this well. So we want to check to make sure that we actually did write to the DynamoDB successfully. I did not have this here until I was writing to DynamoDB. So okay, so then we return. This is why this little trick question was that we have to put on a status code on this. This is usually the thing that gets me the first time I try to write a Lambda on stage or in a hackathon team, is I forget to set the status code and it fails. And then we return back the message, and that's what you saw. And then if there's an error, we catch it and we return that error and we set the stats code to 500. So that's
Nico, I hear you're so good at coding that you never really need a try catch, though.
Yeah, absolutely unnecessary. In fact, the catchphrase that I want to make catch on from my Twitch stream is anytime I change anything functionally, I go SLS deploy and then say, wouldn't it be crazy if that just worked? So yeah, let's deploy that. This will just be with an additional log line, right? There shouldn't be that much different about this, but let's go ahead and do it.
What is SLS deploy? You're using?
Oh, I'm using serverless framework here.
Is this?
Yeah, so we didn't talk about that.
Can we talk about frameworks? What is a framework? Why would I use one?
So okay, from linguistics, we use the term naive to mean the way that you would do it if you just sort of looked at the problem. Like, I don't know, like, if you have an axe and you have a nail to hammer in, you probably use the back of the axe, right? That would be the naive way to do it. It doesn't sound as pejorative as I think it does when I use it normally. Like, the very first Lambda that you do might be, you go and actually paste some code into the Lambda dashboard. So if we go over and look at the Lambda dashboard, which I have, and I want to tell you, I am not logged in as root right now. I'm logged in as a user.
Good. There you go.
I was so embarrassed. Oh, so Noisemaker's in here, yeah. So when we create this Lambda, right, we have a little spot here to like paste in Lambda code. And I don't know if this is going to load or not because I just uploaded it. I think it's updating right now. So that can be a first way that you do Lambdas. And certainly there are organizations out there that are still like pasting in code into this interface all the time to edit their Lambdas. But that's not really the right way to do it. Most notably is stuff like that API gateway that I mentioned, where like no Lambda comes into the world and is useful on its own. Every Lambda is connected to other services to do anything. So sure, with an API gateway, like when you go to save this, it'll ask you like, hey, smart lady, what's triggering this Lambda? Like it'll add and sort of force you to make an API gateway endpoint. But so no Lambda exists in isolation. And then also this ability to just paste something into a page somewhere and have it be your running code is solid for a way to just stand something up in a few minutes, but is not obviously a super scalable approach to running code in production, right? Who knows who made what changes? How do they happen? Who's tracking? All that stuff, right? It's not obvious. So you want to use some kind of tool to deploy all of your components all at once, because that's the other piece. If you write some code that says, well, now I'm going to handle put requests like this, you don't want to have to remember to go over to your API gateway and edit that. You want all that stuff to get deployed all at once. So there are a number of solutions for this. There's, hey, play the game with me, everybody. There's Terraform, there's Serverless Framework, there's Stackery, there's, there's, of course, AWS CDK. There's just using AWS CloudFormation directly.
Got Sam in the chat.
Yeah.
Ding, 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 ding.
Yeah. You got Sam. You got
Eric Johnson's in the chat. And he's You're welcome. You're welcome. We got you, Eric.
So there's a bunch of ways to do it, and a pretty common question that I get is, what's the best framework to use to deploy your serverless stacks? And the answer that I give and that I've seen everyone give is, it's more important that you do one than that you pick the right one. They do similar. They have different features. If you want to stick with an AWS, you should probably be using SAM if you're doing an actual serverless stack. Serverless Framework is very big. Stackery has cool features. They're all really solid tools. But the more important thing is you just want to use one. You don't want to be sitting here looking at the AWS dashboard all the time to try and deploy out your code. You can look at my template here. I'm actually doing something sinful in my template, which I will show you now. So I have my handler defined here, and I have the HTTP methods that can get to it and the path that can get to it, which is cool. It'll just deploy the gateway for me. So this is the whole template. Can anyone tell me what I'm doing wrong here, or what I'm doing like not best practices? There's no DynamoDB table defined here. So I just went in manually and both set the permissions and created the DynamoDB table separately. Yeah, so Yeah. So ideally, you would not do that. You would have it set up here, because the problem is going to be, again, when I go to migrate to another place, someone's going to call me up and be like, "Hey, I'm trying to run your stack, and I can't get it working." It's like, "Oh, right, you got to go into the DynamoDB dashboard and set that up." I did that because I wanted to practice setting up DynamoDB manually and setting up IAM permissions myself. But anyway.
Got it.
But yeah, this is a lot more powerful than you would think. It not only sets up the API gateway, but also I had created this other function on here and gave it the name load, and it was like my testing with DynamoDB. And after I deployed it, I was like, oh, I got to go in and set it to have some IAM permissions now, which I had not set it to have any. And nope, because these are part of the same service, it just automatically gave it the same permissions that the other stuff in the servers have, which makes sense. Like, that's a really good default setting. So yeah, like serverless framework and other tools are very solid ways to create your stuff.
Yep.
Save a lot of headaches, because
you gotta love them.
I guarantee you might, if you're just getting into Lambdas now, you might get a little frustrated with it takes a little while to deploy your code. And so writing the code will be hard right at first, but usually your code's going to end up pretty simple. The much bigger thing that will be your stumbling block is managing these permissions and these connections between services. Like, that's a much bigger part of it than writing the code. Right. If you're writing servers now, the code is just going to be easier, right? There's tons of stuff where, sorry, go ahead.
Yeah, I was going to say, to give Sam some love, I don't know, when I first started playing around with serverless, it was almost always through the console. And for me, there was this like trepidation about using SAM or using any sort of framework. It's like, why would I do this? This is weird. CLIs are not that comfortable. I like the console. It turns out when you start actually like building apps serverlessly, the console kind of becomes a nightmare. It kind of becomes a nightmare when you're doing 1, 2, 3, 4, 5 functions. It starts to get scary, and having a framework there to help you deal with everything, especially the tiny pieces like the IAM that you were just talking about. So nice to have.
Oh, I just want to have, I want to have 5 paths with a couple of verbs on each of them. Each one's connected to a Lambda, and each maybe hits their own DynamoDB table. That's not much, right? That's still just a proof of concept service, but it's going to take you 2 or 3 hours to set it up through the console. It's just a lot of clicking, right? And it's not that this is automatic, and it does that feeling of it's hard to put this Lego bot together, but what if I did it through a claw machine, or what if I used a tool? It's like, that seems harder, right? But it does increase your time to write your first thing, but it is just, it's time well spent.
Yep.
I would compare it to like using GitHub for your code, right? It's like, we generally now are like, even your first couple of code projects, you're going to commit to GitHub, and that doesn't make it easier, right? It's not the easiest way to do it, but it's worth doing. Okay, so this thing is deployed.
It's a good analogy.
This thing is deployed, and we get back. This is one of the other little luxury features. That's kind of how I feel about using serverless framework now, or any framework. Is I feel more like I was at the car rental and I got a luxury car. I'm like, the whole car ride, I'm like discovering little features that has like, oh, that's very nice. Like, for example, I don't have to remember where these API endpoints are. It just returns them to me like, hey, I created them for you, and here they are. In this case, I'll mention, and don't even ask me to explain why. These stayed the same. They don't change with redeploys. Great, cool. Didn't ask. Fine, good. It gives me a little breakdown of what's going on. Okay. So what do I want to do next? Oh, okay. So we can call this thing, but that's not going to be super interesting. We can get logging from it. Yeah, let's talk about what this will look like now when we look at the New Relic stuff. Hey, let's talk about New Relic. 40 minutes in, we're finally talking about New Relic. That's great. So if we go, and there are 2 pieces to having New Relic monitor our AWS stuff. And the first piece is installing New Relic infrastructure logging, which is going to apply account-wide. And so the minute that we deploy our Lambda to AWS, we'll be able to go and see the name of our Lambda with a chart displayed here with this information. So in this case, it's Burrito Shop. It's not Noisemaker, but please don't mind the woman behind the curtain. We're just switching to another dashboard for a moment. But we'll see this information here.
The magic of Twitch.
Yeah, and if we look carefully, and maybe we get some angry typing, in the Twitch chat, someone's like, "Hey, wait a minute, this is just the data you can get from CloudWatch," and it is. This is all it is to start with. Is you just get this without having done any instrumentation. You get just what CloudWatch sees about your Lambda. The biggest thing to think about as sort of the question anytime we talk about observability on any cloud tool, AWS for sure, if you say, well, wait a minute, it's a cloud provider. Doesn't the cloud provider have a lot of information for me about how the code works, right? And it does. When you're facing a problem, like let's say we're looking at this and someone says, hey, on my burrito shop or my tater tot shop, the coupons are taking a long time to load. Well, show me on this or show me on the CloudWatch version how we're going to answer that question to tell you why are coupons taking so long to load, right? This is going to tell you, well, when it gets invoked, well, you have more or less invocations. So maybe that would tell you that people are getting frustrated and they're leaving your site because suddenly you're dropping off. And you can say, okay, well, the duration is kind of standard. So what CloudWatch sees, right, is it sees for Lambda, how long did the Lambda take from starting to shutting down? That might be useful information and really might not, right? It might not really give you the insight that you need to know what's going on inside that Lambda, what's causing you problems. So let's talk about diving a little deeper than that and installing some New Relic instrumentation on this Lambda. So the good news is we don't actually have to edit the code of our Lambda at all. You saw how it happened. Actually, I kind of cut it out of the video because we're talking about other stuff, but it takes a minute to deploy code with serverless framework or right from the console or any other way. So totally outside of how much a hassle it would be if you had hundreds of Lambdas running, there's the fact that if you it takes a little time to deploy new code, so you really don't want to be redeploying code just to do instrumentation. So good news, though. The New Relic CLI can see your functions here, and this is just information that it's getting from CloudWatch. I already instrumented this. Let's pretend that this says no here, but anyway. It gets back a list of the functions that you have running, but to instrument them, we've done to edit the code because we can use the magic of Lambda layers. So Lambda layers, actually, wait a minute. Tell us something I totally forgot to do. We just stepped through a bunch of code, talked about a bunch of stuff. Are there any questions in the Twitch? Do we have anybody who has deep and relevant and meaningful questions? Let's take a look. Not scalable and repeatable. Layers do rule. Thank you for confirming. Sam, squirrels, good. All right.
All right. I think we're good. Yeah, nice.
Yeah. That's pretty bad for me to go 45 minutes before I'm like, hey, does anyone have any questions about any of this? Y'all are here. You would have told me that they were.
It's a part of our job. That's our job. We'll take care of it for you.
Okay. So instrumentation with layers. So what are layers? Layers are an ability to install a code package. Sorry.
Eric has a question for you. Go ahead. Okay. Go ahead and define layers. But his question is: do the layers require an init or a wrapper around the handler?
So the layer, a layer in its package can create that wrapper around the handler. You don't have to add an init. So I think the answer to your question is it's a wrapper around the handler. I know it's a wrapper around the handler. It's not something you have to do. You just have to hit install on the layer. So got me on that one. Sam. Yeah, here's how it works.
He probably knows the answer too.
Yeah, I know.
He said, okay, perfect. He knew the answer.
I said, does anyone have any questions? I didn't say, does anyone want to mess with me? Okay, so okay, let's go ahead and install this. Which is list? Did I say
Braden, were you trying to say something?
No, nothing at all. I wasn't.
Hello, it's me. Oh, right, I gotta give it. Hold on. Yeah. I don't want to cut the stream. So you have to give it your account ID at this point, which I'm not going to do because it's already installed. But you put in a single command, and it will add that layer, and that will instrument your code. So let's go take a look at an instrumented one. And as has come up with a few people who have like hundreds of Lambdas, you can do that all at once. You can install that layer on every single one of your Lambdas all at once. So let's go take a look at that. All right. So now we're seeing, for anybody who is familiar with New Relic from back in the day, we're seeing the thing that sort of back when New Relic was, and it still is, for some people, getting installed on like their self-hosted server or their Ruby app that's running off of a very hot computer in their basement or something, right? New Relic doesn't just tell you, hey, here's how long your requests are taking. It tells you, hey, here's what's going on inside your request. You get these nice stripes of data to tell you, hey, when things take longer, here's what's contributing to it. This data isn't crazy skewy. Let's see if we can see a nice spike here. All right. But it's fine. It's got perfect little spikes in it. You see that there's a total time in here, a total duration. But yeah, the duration of every component of our request of each invocation is broken down. So we're going to go a lot deeper than that into how this Lambda is running in just a minute. But yeah, this is one of the key points is we're not just looking at the Lambda starting and stopping. We're going into what's actually going on inside. And this is nicely aggregated. This is information from every single invocation. So this isn't sampled out, and it's telling you what's happening on average. Now, I'll say our problem, remember, just bringing back the theoretical problem, the coupon service is running very slowly. Well, this probably didn't really cover it. Unless we're really lucky and we have a Lambda that's called like coupon service, where maybe that's like cool. We just need to look at that. Probably that Lambda is all we care about. This hasn't yet broken us down to that point, right? So let's go a little bit further.
Great.
So one thing to note here is we have cold starts listed here. This will actually show us how many cold starts we've had. And this little simulated traffic thing is actually doing really well right now. An hour ago, it had like a whole bunch of cold starts, but right now it's only had one last half hour. I'll pause here just to say, does anybody, Relic layer, all layers. No, we're cool. I really think you were messing with me. I know. It's cool. Don't worry about it. Is anybody not familiar with the term cold starts and want to hear what they are? We don't. It seems like we have a pretty knowledgeable viewership today. So I'm going to skate on it unless. Oh yeah, they did. Wow. That's right. Right when layers came out, and actually this happened both at Stackery and IO Pipe. You had to like go and actually designate a different handler to like push to the layer, but now that's not true. Yeah, so now you can just say, hey, install this layer, and it can have a hook in it that says, hey, before you call the handler, call me, and then it can wrap it. Yeah, it's actually a really good question. I totally forgot about that. But yeah, right when layers came out, Stackery demoed like, hey, we can do PHP on Lambda by like, installing this thing, but you have to go and edit the code. You can just do it, couldn't just do it implicitly like you can now. Yeah, it's pretty cool. Right. It's pretty neat.
I have a question for you.
Mm-hmm.
This is a softball. What is a cold start?
Okay.
And is that one cold start? Is that the answer to your question of why the coupon service is taking so long? Is that one cold start?
Almost certainly not. So cold starts are when, for whatever reason, probably due to inactivity, we've shut down the number of execution environments that we have for a particular Lambda. They happen if you don't call Lambda for a week. You will generally see that environment shut down, and they can also happen when service is spiking upward. It's a really not likely to be the problem here because for two reasons. One, this thing is the whole process order Lambda. So it wouldn't really make a lot of sense for the pattern that we're seeing. Like, why would a coupon cause that to be the one request that's like, oh, we don't have a Lambda available to handle that one? So for that reason, again, if we were looking at a Lambda that was called like process coupons, and it was seeing wild numbers of cold starts, hey, actually, here's a scenario that would totally make sense. If we display a coupon code on our TV ad such that normally we're seeing thousands of orders, no request to the coupon service. And then right when the TV ad plays, we see suddenly thousands of requests. Cold starts could contribute to that, right? And so then you might see not one cold start, but thousands. And yeah, sure enough, it's like, hey, it's not that people don't use the coupon codes in a nice even stream. That's incredibly spiky traffic. And in fact, actually, I'm now thinking about it, one of Jan Kui's examples for cold starts is like, yeah, if you're running a service where you sell breakfast, lunch, and dinner in one area, you might see really rapid growth at 11:55, right? So you got to deal with that. A couple things. Cold starts are not terribly predictable, and they usually don't add a significant amount of time. So that's the other reason we don't usually think of them first. They don't, if you don't call a Lambda for a week and then suddenly call it, you'll probably see a cold start, but you might not, right? Because you're leaving those platform concerns to AWS. You're not necessarily going to be able to perfectly predict it. Also, they don't add that much time.
Are there ways to like?
Oh yeah. So to deal with the problem.
Cold starts, to deal with them. Yeah. Tell us all you know.
Let's say you're going to post your ad out of the Super Bowl, and you know that you're going to get a big spike in traffic, right? For that, there is now permission concurrency. It's been out for, 4 months now? Where you can just say, hey, keep this number of Lambdas available at any given time. Before this, people had done some stuff that didn't work, where they were sending requests constantly to their Lambda. It doesn't really work because the issue is with scaling, right? But you can just say, hey, keep a number of Lambda execution environments available to handle requests. You can set a floor, you can set a maximum, I believe, and you can certainly scale it up and down dynamically by time. And the nice thing about that is, I'll say, permission concurrency can save you some money, because if you provision and you use all that you provisioned, you will save a significant amount of money. I think it's about half or something. It's a good deal off of just running this stuff on demand. Again, you have to see the traffic. You're going to pay either way, so think about that. But yeah, provision concurrency, if you know cold starts are your problem, the solution is provision concurrency. Right now, it's not suggestive. Yep, shoot.
And also even before you even toggle the provision concurrency switch, make sure that everything in your pre-handler code is scoped down, and you're not importing billions of libraries, right? Trim and take care of everything that happens before the actual handler code runs, so that way you're minimizing that init time, right? Oh yeah,
and actually this is a big thing. It's it's a little bit like trains starting to move, where one pulls on the other, right? It's lighter train cars will help, right? So yeah, lighten your code packages if possible. Usually, your team's not going to be that happy if you're hey, get rid of all these dependencies, but it is something to do to improve performance. Another big one, right, is one Lambda calling another can enhance this problem, even without cold starts, right? A Lambda that is slow to start calling another one that is slow to start, right, it magnifies the problem that you have. And so that's actually where we can get into thinking about Event Bridge, where, the most sort of common use case for having one Lambda calling another is one Lambda is well, okay, what is in this event, right? Hey, it's sort of a version of the unstructured issue, right? Where we don't have nice, tidy, requests going to one endpoint that always look the same. It's the Lambda has to open it up and look at it and figure out, okay, where does this go? Well, that's a totally reasonable model to have one Lambda calling another, and one is the API gatekeeper or, router. But with Event Bridge, you can do a lot of that logic just inside Event Bridge configuration, which can save you having to have one Lambda calling another and just cut down the complexity of your system.
So Nico, would you say, and this is my last question, would you say that thinking asynchronously is a big part of being serverless and being a serverless dev advocate? Would you try to always avoid the synchronous Lambda to Lambda calls, or even the API to Lambda calls? Is that do that ever? Or...
Yeah, no, not at all.
Okay.
You have to think statelessly. If you're writing state to some little temporary file system, and then reading state as the Lambda starts up, there's step functions to handle those cases, but otherwise no, right? Generally it's hey, we have this thing, it's not stateless at all. Oh, okay, that's a little bit more of an ask, right? It's a little bit more of a, but yeah, there's no reason not to, it's the idea, right, is that you deploy a whole combination of things very, very quickly. You're able to be agile and see, hey, this has seen a lot of success, and then optimize from there. It might be perfectly optimal code to have some situation where one Lambda ends up calling another in a chain that's 6 long, just because that's one of the possible states for your stack. And that's not bad on the face of it. You're not going to sit down and look at it and be like, I know that your customers hate you, right? Your customers might be like, this is great, you know? So yeah, there's nothing wrong with that architecture just from the outset. But if you're saying, hey, we have these occasional requests or long Lambda startup times are greatly affecting us, in general, not always, but in general, that's usually a thing with large environments like a Java environment or a .NET Lambdas, like they may take a second longer to start up. Then it's like, yeah, if we can avoid it, if we can just have, you know, EventBridge talking to a bunch of Lambdas directly instead of a huge long chain, that's probably better. But yeah, it's not a requirement for how we set up our service. If we have just a one-directional chain, you know, one thing calls another, calls another, calls another, you have sort of broken event-based thinking there, and then that maybe deserves a little bit of examination, just from an architecture standpoint. Because the question becomes, you know, if you have a chain 12 long in every request, it's like, well, what happens if link 3 breaks, right? Like now suddenly the whole request is falling apart. So maybe we want to omit some events and have it be a little bit more complex. Okay, so what was I thinking about? Oh yeah, invocations. And we got memory, right? Again, memory doesn't look like a super, but memory is worth thinking about. Maybe, you know, processing the coupons eats up memory, right? So we want to look for if we're spiking on memory usage. Man, we took up a lot of our time, which is great. But so I'm not going to dive super deep on that right now. Let's look a little bit deeper. Let's look at distributed tracing. So this is going to help us get insight into what's actually happening inside of one request. And what will be interesting here is to take a look at stuff that maybe took a really long time and see what might be going on inside those requests that take the longest time. These are actually, in this example, this is one thing, this is backend API service. It's actually really performative. I need to write my own backend service for demos because I'm a much worse coder than this, and I'll never write something that responds in 800 milliseconds. So, you know, that's for the future. Right now, this is a little fast, but let's take a look inside of it. It's pretty interesting. So we're loading our restaurant's orders, and we're calling, if we're sort of, even when we're looking here, we're saying, hey, you know, this took however long, and this is the, oh wait, I got it sorted backwards, no wonder. Okay, yeah, so there's some in here that took 3 or 4 seconds. We're like, what's going on here? So for these ones that took a good deal of time, we can often get some insight in this distributed tracing where we can go in and see how many spans, how many time spans we have observed. So look at this. This gives us a nice asynchronous view of what's actually going on inside a request, what is adding the time, and what is taking so long. So we can take a look in here and we can see, like, you know, the general question, again, this is observability, how fast can we answer a question? What is taking so long on this request? And it's pretty quick to see that we are making a ton of API calls and they're adding a good deal of time to this request. So we have one out to NASA, probably to get some weather information. We have another one to ICANN IP, makes sense. And then we're hitting the Stripe API, and that's eating up a good deal of our, you know, our 7 seconds for ideal fast responses for customers. You know, 3.5 of them are getting eaten up by the Stripe API. So pretty significant, you know, indicators here. Our MySQL request looks really fast, so this gives us a pretty good map. And you can see that in here, and this is the whole concept, this is what the term distributed tracing means. We're seeing not just what happens inside our application code, but what kind of time we're taking up as we request other pieces of the service. Now, I bet I'll load up the Twitch chat here, but I bet that we have some hardcore AWS fangirls in the chat and fanboys who are like, New Relic, what are you doing? This is just X-Ray. This is just AWS X-Ray. You're biting X-Ray. You're stealing their style. Well, I'll tell you, this is related to X-Ray. It's enhanced by direct code instrumentation. And get this, there are actually a number of, I think I can find them. Let's sorting correctly here. Oh, come on, show me one. Some of the ones that are in here actually are from AWS X-Ray. So 3.5 days ago, we said that we announced that we were going to integrate with AWS X-Ray. And so when you're looking through these distributed traces here, we'll pick up the ones that X-Ray samples as well, whatever your X-Ray sampling rate is, and we'll show them in here right along with our own, with these deep span information of how you're relying on other services. So that's pretty neat. You can do all that with like a checkbox. It's a really cool integration to see running. Let me see if I can grab one here.
Nika, did you, when I Google New Relic X-Ray,
Yeah.
I'm greeted by a blog post by Nika Fee that was released 3 days ago.
Mm-hmm. Yeah,
Could that be something that the...
I wrote something on dev too.
I'll share that with the chat.
Up on the practical dev where I'm just complaining about serverless observability. But yeah, if you want to share the link, that'd be great.
Yeah, just threw the link in the chat.
Okay. Yeah. By the way, if y'all are not checking out the site dev.to, please do it. It's such a rad site. It is such a wonderful place for me to talk about code every day. I'm speaking at their conference, Codeland, at the end of the week. But totally beyond that, it's just a place that I really love working. I don't work there, but I really like putting up my stuff and sharing it. And it's like a really positive environment to talk about your code. Like you can put up your first thing. You can put up stuff that does not work or uses security practices that are very bad, and people be like, "Oh, okay. Like, let me give a few suggestions here. Like maybe we don't want to store that in plain text." And people are so nice. It's a wonderful site. Dev.to.
Nice.
Okay, so, oh yeah, hey, we haven't written any code in a little while, and that's starting to make me antsy. So, I know it's making y'all antsy. So let's write some code. Let's do some little code hacking stuff. Let's come back to this memory monitor. In general, with AWS Lambda, I'm not going to dive too far into why because we're getting up on time for the scripted portion of the evening. But in general, we don't usually want to be downscaling memory too frequently with our AWS Lambda. Reason being, when we have a situation like this, well, this is beyond the limits of scaling. I don't think it can scale this finely. Maybe it can. Maybe you can scale it down to 140 or something. But if you're using 50% of memory, remember that for Lambda configuration, you also scale your CPU and your I/O with your memory scale. So if you cut down to be only using exactly as much memory as like you're usually using to sort of switch to be using 95% of memory, you're going to see your duration start to increase because you're going to have less CPU available as well. Also, you might have less memory. Like that might be a problem on some of your requests. And you might not even save money doing that because you cut your memory, sure, your billing is less, but if your duration starts creeping up, you're charged by the duration length. So it's just not usually we're not too worried about downscaling, but for sure, when we're hitting 99% memory usage, we know we have a problem. So we probably do want to get some alerts from that. So a huge usage case for New Relic for years, as long as New Relic has been around, has been alerting. And, there's absolutely conversation about alert fatigue and being careful about the alerts we create. But I think of alerts as, alerts are my reason that I can safely ignore a dashboard, hopefully for extended periods of time, right? If I'm generating good, useful alerts, then when I don't have an alert, I know I can just not be too concerned about that service. So in this case, I want to generate an alert for this service. And actually, I'm suffering a little glitch. I can't show this, but actually, this guy just had its memory upscaled recently. Like it was using like 90% of memory a lot of the time. So someone just turned up the memory allocation. But that starts to point to a little question I'd have about alerting here, right? If I set the alert to be like, alert me whenever you're using, 190 of our memory allocation, and someone goes and allocates more memory, then that alert's going to be going on all the time, and it's not really going to mean anything. And vice versa, if the allocation goes down, I won't be getting alerts at all because it'll never rise to that level. So how do I, you usually you alert off a single metric, right? You can't alert off of, a terribly complex idea. So how do I get a single metric out of these two values, the memory available and the max memory? All right, let's write a little bit of code. So let's go and New Relic, and let's take a look at this query. So it turns out this chart is actually just the query language query that creates a time series. And I didn't just get lucky.
Does New Relic have its own query language?
Sort of. I mean, we refer to it as New Relic query language. It's obviously just a partial implementation of SQL. So like if you're a SQL a cowgirl, then you'll do fine with New Relic query language. It doesn't do like joins and unions and stuff. It doesn't do like complex SQL queries, right? It just goes simple select statements. But I didn't just get lucky here. We do use it all over the place. All of these charts are based on a single query, which you can go view. And so we can hit view query here, and we can go and explore this. And now we can edit this query to give us a chart that we really think is useful. So in this case, we want to turn this into a single number, right? We want to turn it into a percentage used. So, hey, don't do me like that, interface. Don't start loading. Come on now. Here we go. All right. So let's see. We're getting the 50th percentile now. That's fine. We're calling it max memory use. Let's see. I know I don't want these labels, so let's just pull these out and talk about writing code that works the first time. I don't even like removing labels without knowing that that works. So I'll take out the labels, and then I'll go ahead and hit run here. Make sure that even that edit is working. Okay, yeah. So now we don't have labels on these. You see, let's take a look at what the data is called. It's like, okay, max memory use, CW max memory use. That's doubtless for CloudWatch, right? It's CloudWatch data that we're looking at.
Mm-hmm.
CloudWatch memory size. So, right, makes sense. Percentile and max, those are probably good functions to do on this. So, see, do we want to learn on max? No, it's okay if once in a while something uses a ton of memory. So we don't need to, if we change this to max, which we could do, right? How's that going to turn? I don't know. Let's just explore for a sec. Yeah, it's going to give us much less detailed data, right? Because it's just going to show us what the highest one was in any time period. That doesn't seem that great. Mm-hmm. We're also addicted to Command Z, aren't we? Command Z, it's like we get everything now.
So Nika, is this a process that you go through each time you want to set an alert? Is you kind of just mess around and try to find that golden number you feel is meaningful, yet at the same time predictable?
I mean, there's simpler ways to set up alerts. You can just go and say, hey, create an alert on invocations and just alert me if it ever goes above this number. You don't have to mess around with query. I'm not like a full-time ops monitoring person, so I would recommend doing this. I would recommend taking some time thinking about, okay, what are we really doing with the data here, and looking at what we have. I think that, it's very easy to go in and just say, hey, alert me if memory goes above this, right? But if you start doing that all day, every day, you're going to end up with tons and tons of alerts for things that just don't make sense anymore. So taking a little bit of time to write your query to say, hey, this is really what matters to me. Maybe think about, can we have this apply? Right now, I'm just applying it to a single GUID within my data. Hey, maybe can we think about taking that out so we just have one alert that's going for, the whole account? That may or may not be a smart thing to do. I don't know. What does this do if I take out my where clause? I don't know. What does it do? All right. Data became a little strange there, so maybe not too smart. But yeah, I think it's worth doing. Admittedly, hey, have Alice Goldfuss on the show, and that lady's been jockeying alerts and ops model. Have an experienced SRE on, and I think they may give a different answer. But yeah, I think it's worth. Okay, so now let's do a little math. Okay, I have a degree in this, but I still have to do this every time. It's like, okay, I want a percentage, so I want to divide. I'll take the small number and divide it by the larger number. That's okay, percentage, right, good. Because because usually I could think out as in text, I'm like, what I want is dollars per square feet or something. That's usually my other way, but it's like, okay, now I want memory per max. Okay, not a useful unit to talk about. So let's just run this. Okay. Yeah.
I have a question for you.
Yeah, shoot.
How good at math do you have to be a developer?
Oh, that's a great question. I used to, I got into development through game development like a lot of people. And, you'd sit and you'd see other people demoing code. And you'd see people creating, galaxies that get created at the click of a mouse. And you get people, having whole platforming games, with weapons and explosions and particles and all this stuff. And then you'd see something, you'd be like, oh, how'd you do that? what API call did they use? And people be like, right here, this one time out of this whole day of demos, all the work we did, it's like, oh, I did some math for this. Okay, because that's the reality. Even in game development, which is implicitly usually involves a lot more math, right? It's like, it's a lot of geometry and 3D spaces and all that stuff. Math is just not a big part of it. It can be helpful. Hey, go check out Khan Academy. Go check out. I love this theoretical mathematics channel called Numberphile. Fantastic stuff. It's fun to think about. But you do not have to be good at math to be a developer. You certainly don't have to be good at math to work with data as a developer, which you might think you do, but you super duper don't, right? A lot of that comes down to how what you're doing is implemented in the background, right? Like one of these things, I'm asking for the 50th percentile. I know just enough to know what that means, right? Admittedly, I probably, was taught at one point how to do those calculations. But even, frankly, a Khan Academy video will go a little more deeply than I need to understand what I'm doing. So yeah, if you're starting out and you worry like you were always like not doing great in math class, well, first of all, schools. School is a complicated thing for a lot of us, and so don't put yourself back in a painful place. If you're like, oh my gosh, math was so painful, don't worry about it.
Right.
Go and try some development. And people make big, beautiful, complex things that don't involve math at all. Yeah. Okay, so let's run. This is looking good. It's helpful to remember enough to remember like middle school math in this case. Like, oh, right, okay, to get a percentile, I take the smaller number divided by the larger number, and then right now it'll be expressed as a portion of 1, right? 100% would display as 1. That's not going to be as readable because I know that my bosses know even less math than I do, so they're not going to like that. So let's multiply that by 100. Okay, 70%. Nice. Oh, it's labeled as binop, which is a cool name, but doesn't seem quite right. So let's give it a label as % memory used. Run that. What did I do? Well, why didn't it like that? Oh, weird. Why didn't you like my ads? What do I need some?
So this is unexpected. What is that? Unexpected.
Oh, maybe it's because of the double quotes instead of single quotes.
Single quotes, yeah, instead of double.
Yeah. Oop. Stop messing around with that. Okay. Yeah, that must be it. Now you're happy. Okay. % memory used. Cool. All right. I don't need to show you the new Relic alerting interface. It's really simple, but this, we can just copy this query and paste it into the alert interface. Or there's probably a button in here to say like create an alert from this. And yeah, then we'll have. Now we have a nice consistent number that should be like this calculation should be applicable across all of our lambdas. We shouldn't have to do any rewriting to apply it everywhere.
Nice.
All right, folks. That's been my presentation time, but I'm here. I'm not in any rush.
All right. Braden, do you have any more questions for Nika? Anyone in the audience?
Not yet. I'm looking over here in the chat to see if anyone has any questions for Nika.
So quick plug again. Actually, at this time, every Monday, I am streaming stuff. Usually me messing around with lambdas. I made Noisemaker last week. I might be making a drum sequencer that's totally just front-end code next week, but I promise to get back to serverless soon. But yeah, do dev streaming, have a pretty good deal of fun on there Monday afternoons.
Yes. All right. Okay. Well, I think we can start to sign off. I'm forgetting the sign-offs that I came up with for the show, that AM and I came up with for the show. We had y'all come back now. AM, yeah, Ghost. Yeah. And Ghost, yeah.
Ghost Host is here. Happy trails.
Ghost Host.
Happy trails. Y'all come back now, you hear? Or I forgot the last one. I always forget the last one.
You forgot the last one too. Okay, we only have two. Nika, sign us off. Pick one of the two. Use them both.
See you, Space Cowboys.
See you.
There it is. I like that.
All right. Y'all
sorry.
come back now.
Sorry,
Take care.
Take it.
All good.